light beams work like a Birkeland current too. They show the same distribution and
Really?
rotation that a Birkeland current has. But one of the weird quirks with a laser light beam is if you put an obstruction along the way, it'll disrupt the whole like wave packet. But a Bessel beam, a Bessel Gaussian beam, which is really what we're talking about for even like the solar system and everything, it restores itself not just to more or less another Bessel beam, but exactly the same. How they word it is spatial temporal relationships in the wave packet.
Continuing the Electric View's May 1st show, we will be talking about laser beams, Bell's theorem, the dogma of scientific belief, and how this relates to the stars. Please like and subscribe below.
So if what you're talking about on the solar system scale is if our solar system really does travel along a Bessel Gaussian beam, then even if you have major changes, you can justify it with these same cycles because the whole dynamic should return not just more or less the same, but almost exactly the same as it was. And that's how you justify from the mythology, like Hamlet's Mill. They just go into great detail on the cyclical nature of things, and that's what's passed down in the Indian traditions, the Yuga cycles and Mahayuga cycles, the consistency of one to the next. And that would seem to be like just totally at odds with catastrophes, but it's not because of that. You know, the Bessel beam gives you the answer to how.
I'm also very interested in whether or not that your ideas would solve Bell's theorem, like the when you put two, like if you have a polarized light filter and then you put another polarized light filter and you turn it at 9 degrees, of course, it will block out all light because now you have two polarized light things going in the opposite direction. But weirdly enough, if you put a third one on top of those two and turn it to 45 degrees, it will let all the light through. And that's I keep on wondering about that spinning idea of light as it goes through space that you were just talking about. There, the video one. Right there. Yeah, the Venn diagram thing. And HBO.
HBO, yeah.
But anyway, it was just like it was a little, that part. See, if you take two of them and you put a third one, see, it will brighter in the over top of three. That shouldn't be. But why is it? And that type of thing. And I wonder about stuff that you're talking about with regards to your curves. I don't totally understand, but it seems to be that type of thing where it keeps spinning as it goes through space. It should.
Right, that was one of the first things that got me looking into the light thing. Is you know how they have this
it makes you question. Sorry, it just makes you question. This is the part that makes me go, I think that you have a problem in physics, or you have a problem of quantum mechanics. Your theory should be more fleshed out. Go on. Sorry.
Oh no! The first thing I stumbled on was that when they show you a picture of how the electric field rotates in a light beam.
Right.
That's the same thing that should be happening in our solar system. If you want to draw an electric field between like the sun and a planet, then if our solar system really is propagating, along the towards the north ecliptic pole, then the electric field between those things does rotate the same way. We have basically the same kind of dynamic, in other words. But then, all you need to be aware of is that they play around, like in the lab, all the things that we talk about with Birkeland currents in space. They do with laser light beams. They can get them to spiral around the background magnetic field, and
wow.
They do everything that a Birkeland current does. The same distribution of matter into, like, they call it lobes, but it's really the same, like, it's shells of intensity. And so it's the same thing on just a much tinier scale.
Mm-hmm.
But then all the fun comes is when you compare, like, what they know about light in the lab. If you apply that stuff to the solar system scale, you can get insights that you could obviously never test in the. We're not going to pass the solar system through an aperture, for example.
Right.
No, you're right. But you see, it's these things. When I hear about your work and stuff like that, I think about stuff like this and wondering, what am I like? We're missing stuff. I feel strongly that and you're right. If you can just get a grip on what you're really looking at, I think that we'd solve a lot of problems. And I think that this is one of the avenues that we're going to use, obviously, in the future. But
yeah, there's so much to research out there.
Well,
like after a conversation I had with Edwin about the metallicities of stars, that threw me into reading up on that.
Yep.
All it is, though, is totally upset. You can see that every theory that they have has a huge number of exceptions, and that makes you wonder if any of their theories are right. Like, they've got the basic idea that metallicity is a function of the stellar ages, and then you read all these quirks of two stars of seemingly the same age, why one has a higher or lower metallicity than another one. So
yeah.
It's like, okay.
They wouldn't admit that one was probably barfed out of the other one. They don't want to ever say that, anything of those natures or anything like that.
The only thing I'd like to interject there is
interject away.
It's quite simple, and it's wrong science what they're doing. I'm sorry to say, because they're working towards the preferred answer, right? That becomes a dogmatic belief system. And when you do that, then only you do the cherry picking. You're doing the deceiving to yourself. You're ignoring facts that contradict and la-di-da-di-da. And in the end, you find yourself trying to convince the world of your own mistakes. That deep down, they are there, right? And that's the situation they're in. We are in at the moment, I believe.
Yeah, I think not only is it, I think it was Thomas Harding that said science dies when it adopts a creed, or and of course I've said in response to what you said, Jim, if you want to find a new theory, you take something that answers all the anomalies. You look for all the anomalies in a theory, and then you go, okay, what would answer all of those? That's a good way to find a new theory, in my opinion. And it actually, I wasn't the first person to say that. Something similar was said by Thomas Kuhn there in his Structures of Scientific Revolutions I found later. But, you need a revolution occasionally, because this evolution shit gets corrupted, as we've seen.
Well, it ends up being a power structure, and then ultimately dogmatic.
Self-sustaining
orthodoxy.
No one's ever going to destroy themselves. Let's tear down the foundations of our own institution. What a great idea!
You realize what it is. I mean, this is the beauty of Sheldrake. Yet again, it's the problem of material. It's like they got the double whammy. It's not only they don't admit it's a dogma to begin with. And it's like it's firmly based in this materialistic view. It's like you're screwed with this with this one angle of like you have a dogma. It's philosophical materialism.
Well, it becomes a belief structure as opposed to. I mean, people don't.
Yeah, no, it is. Exactly.
People don't actually know science. They believe science.
They believe in science. I know. I believe in science, and then I've heard that so many times. It's like, what are you talking about? It's like, do you believe in questions? By possible answers and hypotheses. It's like you believe it. Oh no, I believe what that. 97. I've seen this so much over the last 10 years.
Yeah, well, they think that science is a method. Yeah, and it is, but
yeah, exactly. It's a method. It's not a knowledge base or a Wikipedia. That is not science. Knowing stuff is not science. Not knowing stuff and figuring it out how it fits together. That is science, right? The method in a proper way of figuring out stuff. That is science.
and some people don't recognize they that's something that also happens is that people, especially scientific literature, said proof, like this proves this, and it's like you're like, no, that can't be right. It's just not wrong yet. Like that's all it really means. It's like because if I can describe an interaction of two objects hitting each other in the force of newtons, and I can use all of the, this kilogram hits this, and and has this is how much inertia, how much momentum, all of that jazz. I can put it in there. I do the calculations, and I feel smart when I do. But I can also describe the entire thing in just electrons and protons. Does that make one wrong? Well, no. Once for classical has its application in the real world. No one's going to start calculating electrons for, say, building a machine. But you're going to certainly do it over here in this particular aspect because you're working with looking for a different answer. Doesn't make them wrong.
Not a machine, but in transportation world, it's going to be maybe critical.
Well, that's what I meant. Like there's a different things for different applications, and
yeah.
Like you work on electron volts, I work on volts.
Now, you have something as a tentative question. It's something that just if you know that, like in the EU model, that stars can go from red to blue or blue to red as a function of current density. So then, if there's correlations between metallicity and what they think is stellar age, in other words, really how red or blue something is, and that's reversible, that means that we would have to say not just fusion, but also fission must have to happen in parts of those solar cycles to get back and forth to this, So that's what I'm considering as maybe an option to look into it. In that, if we see if stars do go from red to blue and blue to red, then and there is a correlation between ages at all and metallicities, we should be able to see.
Yes, and I believe there is definitely a correlation to the abundance of the element that is at that particular moment active in a fusion phase, if you will, right? And that is correlated, of course, to the age of the star, as in, I postulate that, of course, the more heavier elements you see, right, the older it will be.
But is that the question? Is that reversible? Though? Like, could we have like a star in some state then where there's actually more fission, more returning to?
Probably not, because from iron on, that's why we pointed out iron the last time, I believe. Mm-hmm. From iron on, the fusion reactions become endothermic, meaning it no longer yields energy, right? So any heavier element than iron means it was already more or less an endothermic reaction. We see that evidence because uranium, when it splits, right, it yields energy again. That's the reverse. So below iron, it's exothermic. Above iron, it's endothermic. And for fission, it's exactly the reverse.
And you're going to have a situation where
it's like automatic brake on the process, if you will. Therefore, I believe they cool off, die off, stop fusing, whatever, right?
Well, it won't stop.
Maybe they accumulate enough material again. There might be phase.
Well, no, I mean, they could blow up. I mean, certainly. But the thing is that you're going to have a current will go through, and if it has a higher resistance, it's going to generate more heat, and then you're going to have this ability to do exactly the fission process all the way down until it turns into a solid chunk of iron, so to speak. That right. Chunk is still going to, it's going to have a high flow, it's going to have a high magnetic field, but it's basically going to move along. If you were talking about power curves, you would basically be pushing from a more resistive force to a more inductive at 90-degree angle to the power. So that's instead of basically dealing with watts,
becomes the shortcut, if you will.
Well, yeah, but what happens is that you are aware of like for example, if you have a zero power curve, you have a purely resistive power, and if you start putting more more magnetic energy across it, you'll get a resistance, but it's not really a resistance. It's an inductive resist. It's a reactance is what it is. So it's at 90 degrees on the power curve to the resistive. So it's going to start pulling up more and more to the 90 degree angle because it's getting more and more metal, and it's more and more of an inductive load compared to the resistive load. So that there's still going to be energy being used there, and it's going to mangle anything that gets near it. Like it might rip up parts of its chunks and still have energy to do stuff and still glow, but it won't be doing it the same way as the other stars was, because the other star was basically just making heat because it had all this resistance to it. But now it's like, whoa, I have much more magnetic resistance now, which is called reactance basically. But it changes the power curve. Oh, yeah, God knows. I don't have no idea what it is yet. I'm not studying this. This is brand new. Well, what you told me blew my mind. So,
what you describe is kind of like a cooled down sun. Instead of millions of degrees, you get like a white dwarf, I believe, is 25,000 Kelvin or something. That kind of fits what you described there,
Yeah, it would definitely have strong magnetic field, of course, is what I'm saying. And but again, I'm not. I mean, this would take. We're just at the beginning of this. This is a whole brand new thing to me. I'm basically, I feel hesitant to make any more deeper theory than that, after one day of mulling it around, or 1 week of mulling it around in my head,
But for mainstream, it's more or less a mainstream idea, mind you, because the supernovas allegedly reach the phase where it's all metal, like iron and nickel.
Right.
Again. So basically a big iron core, a big one, a real big one or something. I don't know how big it is. And then allegedly that thing explodes. And then the heavier elements can be formed because, remember that energy story, you need now extra energy to create heavier elements. So you need to put in extra energy. It doesn't yield it anymore. And only because of the supernova, those heavier elements get created. Therefore, all the gold from Earth comes from the supernova. Unless you put electricity into the equation and you zap iron, under certain circumstances, they might, become even heavier elements, fused with lighter elements. That would be my hypothesis.
Well, remember, once you get more magnetic confinement, you get more concentrated electricity, basically. Because once you get more and more metal, you're going to have higher and higher inductance. You're going to have much more concentrated spherules on the surface. So imagine it's not great big wide ones, many kilometers across or 1,000 kilometers high. Now they're pinched more, and you could imagine that. We were talking about that when we were looking through, like Andy was going down Sedona, and we were going through West Forks, and he saw this big curve across the as it etched out underneath of a lip, right? And he was like, wow, it came up like this, and then it looked like it got wider. And I go, yeah, because look right here. And we found this great big glob of basalt, and I go, it just dropped its metal. So as soon as it dropped its metal, it was like no longer having as much magnetic confinement. It was fanning out, doing stuff like that made you. Like when I explained that to him, it's like, oh shit, that's right. Like he was cluing into because he's a mechanical engineer, right? So he looks at things differently. And if we all looked at things the same, how boring it would be. So.
Well, actually, I think that's the strength of the different angles, the viewing angles, or your different approach, your own model. And I think we have a whole bunch here. Right, and I think that is actually quite powerful because we have a different perspective. We look at the same thing from a different angle. I can tell you, Neil. Well, Neil, from my view, it looks like that, and you go like, well, I'm standing here, and it looks like that, and I go like, well, that's amazing, but that must be the part that I'm not seeing clear because that's what he's seeing, right?
And then Andy would go in, look at the shockwave across this, and then Jim goes, don't forget, this happened before.
Yeah,
it's very nice.
Your own thought process,
but that's good
because you're sensitive to the other's perspectives, and it changes the own. It's its own like kind of little chemical thing going on. So it's interesting as far as just perception goes.
I totally agree.
So mainstream thinks iron cores are created too in stars in the end, and then they blow up. Or die out as a white dwarf. Well, there's your answer. Still a metal core, right?
Right.
I'm just not so sure about the blowing up part.
Thank you, by the way, Edwin.
Yeah,
That's exactly what I'm going to do there. So you made our intro. A trailer, because I was looking for something for the trailer, and you were like, "This is the strength of our group right here." Blah 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 blah. And I was like,
Right,
"Perfect,
no,
perfect."
Oh, there you go. Right. Yeah,
That's exactly what it's going to be right there.
Perfect.
Oh God! I'm not listening to all of them, but last one I caught one. What did I say at the end? You cut it off right there, Neil. I thought it was amusing, and I said, "Are we going to the future now?" And then boom, end. And I go like, "You